Hello, my dear students. How are you? Hope you all are very fine and safe in home. We are talking about different types of enthalpy change, and already we have discussed the enthalpy of formation and enthalpy of combustion. Today, I am going to discuss about enthalpy of neutralization. All you know what is neutralization reaction. And enthalpy of neutralization, that means the change of enthalpy which is occurred in neutralization reaction. You could understand by seeing this name, enthalpy of neutralization. In enthalpy of neutralization, there is a little bit difference, and that is an important information. So, what is enthalpy of neutralization? Look here. The amount of heat produced in neutralization reaction between acid and base to form 1 mole of water at room temperature is called heat of neutralization. Look, the reaction between acid and base to form 1 mole of water. That is the important information. 1 mole of water. Now, look, in neutralization reaction, water is produced. In every neutralization reaction, water is produced. But that water, not all time 1 mole. It may be 1 mole, 2 mole or 3 mole. But enthalpy of neutralization, that means the change of enthalpy which is occurred in a neutralization reaction when 1 mole of water is produced in this reaction. Look, neutralization reaction is an exothermic reaction. So, heat of neutralization is a positive value. For example, at 25 degrees Celsius temperature, 1 mole water is produced by the reaction of dilute HCl and dilute sodium hydroxide. And 57.34 kilojoule heat is produced in this reaction. So, heat of neutralization of this reaction is minus 57.34 kilojoule because 57.34 kilojoule heat is produced. That is an exothermic process. So, heat of neutralization of this reaction is minus 57.34 kilojoule. That means del H of this reaction is minus 57.34 kilojoule. Now, some more examples of enthalpy of neutralization are, look, this is also a neutralization reaction. Reaction between sulfuric acid and sodium hydroxide. In this reaction, after balancing, 2 mole water is produced and del H equal minus 114.88 kilojoule. That means 2 mole water is produced where enthalpy change is minus 114.88 kilojoule. Now, dear students, can we tell this enthalpy change as enthalpy of neutralization? No, because here 2 mole water is produced. But the condition of enthalpy of neutralization is there will be 1 mole water produced. So, if we divide the full reaction by 2, then we will get half mole sulfuric acid reacts with 1 mole sodium hydroxide and produce half mole sodium sulfate and 1 mole water. And here the heat change or enthalpy change equal minus 57.44 kilojoule. That means the heat of neutralization of this reaction is not minus 114.88 kilojoule. It will be minus 57.44 kilojoule. This is another reaction. This is also the reaction of acid and base, and here 1 mole water is produced. So, heat of neutralization of this reaction is minus 57.35 kilojoule. Acetic acid and sodium hydroxide, this is a neutralization reaction and heat change of this reaction is minus 55.14 kilojoule. So heat of neutralization of this reaction is minus 55.14 kilojoule. Now heat of neutralization of strong acid and strong base. Now we will discuss about the heat of neutralization, but the neutralization reaction will be between strong acid and strong base. Look, this is a reaction between sulfuric acid and sodium hydroxide. Both are strong, and here heat of neutralization is minus 57.44 kilojoule. Another one, nitric acid and sodium hydroxide. Both are strong acid and base, and here the heat of neutralization becomes minus 57.35 kilojoule. This reaction already we have seen before. Here the heat change is minus 57.34 kilojoule. HCl and potassium hydroxide both are strong, and here the heat change is minus 57.43 kilojoule. Now students, look all these examples. Here the reactions are between strong acid and strong base. Now look the heat of neutralization of these reactions: minus 57.44, minus 57.34, minus 57.35, minus 57.34, and minus 57.43 kilojoule. Now look there. Is this not interesting? Here all the reactions, they have almost equal heat change. That means heat of neutralization of these reactions are almost equal. How this is happened? Look, here all the reactions are different. All the acids are different. Bases are not same, and they produce the salts. The salts are not same salt. Only the product water is same for every reaction. So how the heat of neutralization of all these reactions become equal? There is an important information. Look, strong acid and strong base, they are 100% ionized in solution. So when strong acid and strong base react together, they will produce salt and water, and their heat change will be approximately minus 57.34 kilojoule. That means the heat of neutralization of strong acid and strong base is a constant value, and it is minus 57.34 kilojoule. Now, why this heat change is a constant value? Heat of neutralization of strong acid and strong base is always minus 57.34 or near about minus 57.34. Why? Now, let us see this example. Here, hydrochloric acid, strong acid, sodium hydroxide, strong base, and they produce salt and water. You know that strong acid and strong base are ionized 100% in solution, and the produced salt, it is also a strong electrolyte, so it is also 100% ionized in solution. Now, dear students, do you know why heat change or delays is occurred in a reaction? What is this delays? When any reaction happens between two or more reactants, then the bond of reactant molecule is broken, you know this, and new bonds of product molecule is formed. You also know this. Now, you know that when any bond is broken, then a fixed amount of energy is needed to break this bond. That means a fixed amount of energy is absorbed by the reactant molecules, and when new bond of product is formed, then a fixed amount of energy is produced with these product molecules, with this bond formation of product molecules. But look this reaction here, HCl is 100% ionized. That means no bond is there, so no need to break any bond. Sodium hydroxide is also 100% ionized, so here also no bond is broken. That means in this reaction no bond is broken and no energy is absorbed by the reactant molecules. And in product sodium chloride, this is also ionized, and here also no bond is formed, only the ions are seated side by side, so no bond is formed in sodium chloride. But here only one bond is made, that is water. Hydrogen and oxygen, these two atoms make this bond water, and other two ions, sodium ion and chloride ion, they are spectator ions, and only one bond is formed. And in every neutralization reaction, acid, not only every neutralization reaction of strong acid and strong base, the acids are ionized 100% and the bases are ionized 100%, and only one bond, that is water, is formed in neutralization reaction between strong acid and strong base. So to make this bond or to form this water, 57.34 kilojoule heat energy is produced. So in every neutralization reaction between strong acid and strong base produces 57.34 kilojoule heat energy. So heat of neutralization of strong acid and strong base has a constant value, and that is approximately minus 57.34 kilojoule. Look, this is 100% ionized. This base, this is also 100% ionized. So when strong acid and strong base react together, the cation of base and the anion of acid make salt just by changing their position but not making any bond. This sodium chloride, there is no bond. Here only hydrogen ion of acid and hydroxyl of base join together to make water. These two ions make water. And 57.34 kilojoule heat is produced for the production of 1 mole water. So the heat of neutralization of strong acid and strong base is a constant value, and it is minus 57.34 kilojoule approximately. Now we will talk about heat of neutralization of weak acid and strong base. We got that the heat of neutralization of strong acid and strong base has a constant value, but heat of neutralization of weak acid and strong base, like this acetic acid, weak acid, and sodium hydroxide, strong base, and their heat of neutralization is minus 55.14 kilojoule, that is less than minus 57.34 kilojoule. Why? Why the heat of neutralization of weak acid and strong base is less than strong acid and strong base? Strong acid is 100% ionized in solution, but weak acid, is it 100% ionized? No. Acetic acid is only 5% ionized in solution. Its ionization is only 5%. But sodium hydroxide, it is 100% ionized. So when neutralization reaction occurs between these two, then acetic acid is also ionized 100%. How? Because some energy is absorbed by acetic acid to ionize it 100%. Here, almost 2 or 2.2 kilojoule energy is absorbed by acetic acid, and after absorbing 2.2 kilojoule heat energy, the total heat energy produced in this reaction is less than 57.34 and it becomes 55.14 kilojoule. So the heat of neutralization of weak acid and strong base is less than minus 57.34 kilojoule. Look, acetic acid is a weak acid, so it is ionized only 5% in solution. During the neutralization reaction, acetic acid is gradually ionized. How? Because some energy is used up for this ionization. That means 2.2 kilojoule energy is used up by acetic acid. Hence, the heat of neutralization becomes less than minus 57.34 kilojoule and it becomes minus 55.14 kilojoule. Now, heat of neutralization of strong acid and weak base. Same phenomenon occurs here. Here also acid is ionized 100% but base is not. The ionization of base is less. So some amount of energy is absorbed by the base to ionize it. And so the net energy or the total energy that is produced in a neutralization reaction, that is called heat of neutralization, is less than minus 57.34. This is an example. Ammonium hydroxide, it is a weak base, and hydrochloric acid, it is a strong acid, and they produce ammonium chloride and water. But here the heat of neutralization is minus 51 kilojoule. That means more than 6 kilojoule heat energy is less produced here. Here also ammonium hydroxide is only 5% ionized and HCl is 100% ionized. But when they react together, then during the neutralization reaction, ammonium hydroxide is fully ionized by absorbing some amount of energy, about 6.34 kilojoule energy. So the heat of neutralization becomes less than minus 57.34 and it becomes minus 51 kilojoule. Now, heat of neutralization of strong acid and weak base, or weak acid and strong base, we learned. Now, if the acid and base both are weak, then what will happen? So now we will read about the heat of neutralization of weak acid and weak base. Ammonium hydroxide, it is a weak base, and acetic acid, it is a weak acid. But it is also neutralization reaction because the reaction is between acid and base and they produce salt and water. And here the heat of neutralization is only minus 44 kilojoule. Look, in every reaction, weak acid, weak base, but they produce salt and water. And here also water is produced. And we know that to produce 1 mole water, 57.34 kilojoule heat energy is produced. But here, minus 44 kilojoule heat energy is only produced. Why? Because here acid and base both are weak and their ionization is only 5%. But in neutralization reaction, some amount of energy is absorbed by ammonium hydroxide as well as acetic acid, and the total energy is less than minus 57.34 kilojoule. Here, heat of neutralization of ammonium hydroxide and acetic acid is only minus 44 kilojoule, and this is very less than minus 57.34 kilojoule. This is only 5% ionized in solution. Ammonium hydroxide is also 5% ionized in solution. And when acetic acid and ammonium hydroxide react together, they are ionized only 5% in solution, but during the neutralization reaction, both acid and base should be fully ionized by absorbing some amount of energy. That means 13.34 kilojoule heat energy is absorbed by this ammonium hydroxide and acetic acid to ionize them fully. So the heat of neutralization becomes less than minus 57.34 kilojoule and it becomes minus 44 kilojoule. Now we will read about an exception, that is heat of neutralization of hydrofluoric acid and strong base. Do you know about hydrofluoric acid? What are you thinking? Hydrofluoric acid is a strong acid or weak acid? Look, here hydrofluoric acid and sodium hydroxide, they also react and produce salt and water, and here heat of neutralization is minus 68.6 kilojoule. How more energy is produced here? Minus 57.34 and here minus 68.6 kilojoule. Now, what do you think? Hydrofluoric acid is more stronger acid? No, dears. Hydrofluoric acid is also a weak acid and its ionization is only 16%. So why so much heat energy is produced here? Because there is a clue. Look, heat of neutralization of hydrofluoric acid and sodium hydroxide is minus 68.6 kilojoule. So heat of neutralization of hydrofluoric acid and strong base is more than minus 57.34 kilojoule. Why? I told that hydrofluoric acid is a weak acid and it is ionized only 16%. But sodium hydroxide, it is strong base, so it is ionized 100% in solution. And I told that some energy is absorbed by the weak acid or weak base to ionize it fully during neutralization reaction. Here also same phenomenon occurs. Here hydrofluoric acid absorbs some energy to ionize fully and total heat of neutralization becomes less than minus 57.34. But look, hydrofluoric acid is a weak acid and it is ionized only 16% in solution. During the neutralization reaction, to ionize hydrofluoric acid completely, some amount of energy is used up in this reaction. So the heat of neutralization of this reaction should be less than minus 57.34 kilojoule because some energy is used up by hydrofluoric acid. But why the heat energy is more than 57.34? Look, hydrofluoric acid, when it is ionized, then hydrogen ion and fluoride ion is produced. Fluoride ion, it is the smallest anion. Size of fluoride ion is very small and it is the smallest negative ion. And its charge density is more. You know that anion, that means its charge density is more and it is the smallest anion. That means in second shell there are 8 electrons. So the charge density is more in fluoride ion. Therefore, association of fluoride ion with water molecule is closest and strong. Fluoride ion absorbs water molecule and it forms hydration reaction. Fluoride ion is joined with water molecule and some energy is evolved as hydration energy. You know, hydration reaction is an exothermic reaction. So when fluoride ion is associated with water molecule, it is joined with water molecule, then hydration reaction occurs and some amount of energy is produced as hydration energy, and this hydration energy is very more. This hydration energy is maximum, and this hydration energy is added with the heat of neutralization of this reaction. Hydration energy of fluoride ion is little bit more than any other negative ions. So, excess hydration energy of fluoride ion is added with the heat of neutralization value, and the heat of neutralization becomes more than minus 57.34 kilojoule, and it becomes minus 68.6 kilojoule. Now it is clear why the heat of neutralization of hydrofluoric acid with not only sodium hydroxide, with any strong base is more than minus 57.34 kilojoule, because the negative ion fluoride ion, it is joined with water molecule and hydration reaction is occurred here. So the hydration energy is added with heat of neutralization. So my dear students, today up to this we have discussed details in heat of neutralization. So goodbye everyone.